This will be a start of our series of notes in our homework log, in which we will feature problems similar to what you will have in the homework, but we're going to use for our class work practice, topic 1.1. Now, as you number these in your booklet, we'll number these with a little square, as opposed to later when you do your homework, you'll be numbering those with a circle. Okay, so this will be number 1. You don't have to write everything down, but some of this. We want an integer between 11.3 and 12.3. Now, what is an integer? I'm going to go over the sets of numbers that we've used in our flipped classroom video. We said the first set of numbers were the natural numbers. The next set were the whole numbers. Next set were the integers. This is the ones we're looking for here. Then we had rational numbers, and then irrational numbers. And then all of these sets made up all the numbers on the number line, which are the real numbers, which is what we're featuring in topic 1.1. So let's see if someone knows this answer. So all you would have to write down is this. An integer between this and this is, and if you said 12, that is correct. Now, before we go on, I'm going to ask a few more questions about the sets of numbers. Now, put this in your homework log, number 2, with the square, and you want to write an irrational number that is between the square root of 17 and the square root of 19, and you are to pick out one that would be appropriate, or if there's more than one, you would select that. All right, the correct answer is the square root of 18. Now, if you chose 4.24, this is an approximation of this number. Well, this number is irrational. This one is not irrational. I'm wondering if someone can tell me why. Because the decimal terminates. This is not irrational. All right, let's go on. So this example we'll call number 3. And for A, I just want you to write natural numbers. For B, and leave a little space, whole numbers. C, integers. D, rational numbers. E, irrational numbers. And F, real numbers. So we'll give you a little bit of time, and then I'll be asking people for these, and you're going to use this as your sample field. So in summary, something like this, keeping in mind that the square root sign is an operational sign saying, take the square root of this. When you do that for 30, the square root of 36, this is going to be 6, which is a natural number. But as you put this into the software, you would use the radical sign. All right, does anyone have any questions on these? Let's go on. Now, for number 4, and label that in your booklet. Here we're saying a peak of a mountain is this many feet above sea level. How would you write that as an integer? Now, the answer is going to be 19,850, positive. So when a number is positive, we do not write a sign. Now, sometimes they will ask you about a trench in the ocean. So this is sea level, which we say would be 0. And then to indicate the negative distance of that from sea level, we say that would be negative 20,250 or whatever it was. All right, so a little background and then the use of signed numbers. Now, for number 5, you're going to create a number line. And in your booklet, just by number 5, you're going to make a number line. And here's our number line. Now, when you use your software, you're actually going to be able to take this point and drag it to the various places. But for us, in this example, all I want you to do is, create a number line, put your values there. And since these are all negative, we can just say this is 0, -1, -2, 3, 4, 5, 6, 7. And now plot these on the number line, dragging these points, and we'll just put a point on the number line. So -4 is here, -6, and -5. Now, this would be the graph of these values. So that was sort of an easy one. Now, for example 6, we'd like you to write A, additive inverse, B, absolute value, and then take a moment to answer this, and we'll ask the questions. So the additive inverse of 28 is its opposite, -28. And the absolute value of 28. And we write absolute value with vertical lines. Again, this is an operational symbol, is its positive value. Now, as sort of an extra question, what would this be the answer of here? And we'll pause. All right, this comes out of the absolute sign as a 28, but then we apply this negative sign that is outside. Or we can think of this as a -1 times the absolute value of a -28, which is a positive 28. -1 times 28 is a -28. This will be example 7. You write that in your notes, and the statement that you will write by it is, select the lesser of these two numbers. And the answer is a -13. Again, if we were to put these on a number line, and that's always a good way to compare numbers, -13 would be there, -9 would be there, sort of, and anything to the right of something on the number line is greater than anything to the left. So the lesser would be what would be on the left. A little bit of background. Again, if you have a question, be sure you're asking. For number 8, you're going to put these two absolute values down, and you want to select the smaller. Now, to do that, you have to evaluate because, again, absolute signs are an operational thing. The absolute value of this is 15. The absolute value of this is 12. So the smaller, in this case, would be letter B. Now, for number 9, you're going to write this statement down and then state whether the statement is true or false. So it would be 3 is less than or equal to. Now, the opposite of a negative 4 is a positive 4. Now, is that true or false? Well, we said that if in this inequality symbol, if part of it is true, then this is true. And 3 is less than 4. And if we had something like this, 4 is less than or equal to 4. Again, now the equal part would be true here. But if we had 5 is less than or equal to 4, no part of this is true, so that would be false. Again, some background and review. One more to go. Now, for number 10, take a moment to write this statement down here. A negative of an absolute value of negative 19 is less than or equal to the opposite of the absolute value of a negative 13. So again, we have to do some calculations. This becomes a positive 19, but then we apply the negative to it. Here, this becomes a positive 13, apply the negative to it. So when we do that, is negative 19 less than negative 13? Again, if we put it on a number line, there is 19, there is negative 13, and 13 is to the right. So part of this is true, so therefore this is true. Okay, this will wrap our first classwork practice of homework in our course, and you got an idea how we're going to use it.